Hi, Bianca here. Yesterday we talked about putting all the trick stuff together, how to sketch an angle and standard position and degrees, and all the reference angle, coterminal stuff. So today what we're going to be doing is talking about the radian measure. Now, a radian measure is just another way to talk about the measurement of an angle. And you watched a video already about, how do you actually get a radian? What does it represent? And thinking about the angle coming from the center, it's a specific scenario where your radius is equal to the arc's length, and that's r. So we're going to be talking about how to actually convert from degrees to radians today. So if you want to think about it, we know that 180 degrees is actually equal to 1 pi radian. So if we wanted to go ahead and convert, I always think about some type of fraction, and I think about it in words, and I want to compare degrees to radians. So I have like a word fraction here. And we know that there's 180 degrees, which is equal to 1 pi radian. Now let's say I wanted to convert, 30 degrees, right? If I wanted to convert 30 degrees to radians, what I would do is set up a proportion. That's going to be equal to, well, notice my degrees are going to be in the top or in the numerator. So 30 degrees is going to go up top, and that's going to be equal to, or over x. So notice 100 over 80 is over pi is equal to 30 over x. And what we want to do is solve for that x measurement. So we're going to cross multiply here. So solving the proportion. 180x is equal to 30 pi, and we're going to divide by 180 in order to get that x value by itself. Now we do have to go ahead and simplify. We know that the zeros are going to cancel out, and we're looking for a number that goes into 3 and 18 evenly, and that's going to be 3. 3 goes into 3 once, and 3 goes into 18 6 times, so it's going to be 1 pi over 6. So pi over 6 is the radian equivalent to 30 degrees. How can you go in the opposite direction? Well, let's say I have pi over 6, right? Let's just do that over here. If I have pi over 6, and I want to see what is that equal to in degrees, think about it. 180 is equal to pi. So all you want to do is substitute that in. 180 divided by 6. We'll divide that out. 18 divided by 6 is 3, and then you have that 0, so you're left with 30 degrees. Just a quick way to go ahead and figure out the relationship or how to actually convert from degrees to radians and vice versa. Let's look at the unit circle in radians. So remember, we always start off at 0 degrees. We then go to 90 degrees, 180 degrees, and 270. So if I wanted to label these in radians, I know that 180 is equal to pi. So know that this is pi over here. Now, if we want 90, we know that 90 is half of 180, really. So we would take pi, or 180, and divide that by 2. So pi over 2 is going to be 90 degrees, or the label up at the top. So the way I like to get the third one, instead of doing the conversion, which we totally can do, so let me do that on the side first. Degrees to radians. We know 180 degrees is to 1 pi radians, and we're looking for 270 degrees. And we want to know what is that in radians. So we want to cross multiply. We have 180x is equal to 270 pi, and we're going to divide by 180 here. X is equal to, the zeros go away. We know 9 is going to go into both, so we have 3 pi over 2. So that's what it would be in radian measure. Now let's think about how you get that. 3 pi over 2. I like to count 0. I have 1 pi over 2, because each quadrant is going to be pi over 2, or 90, right? 1 pi over 2. I have 2 pi over 2, which 2 pi over 2 we know is equivalent to pi. I have 3 pi over 2, and I have 4 pi over 2, which is equivalent to 2 pi. So we know that 360 degrees is 2 pi in radians. So that's just labeling our unit circle here. All right, so let's sketch out these 2 examples. How do you actually sketch an angle in standard position if it's given in radians? So I'm going to go ahead and just kind of sketch out my axes. And we know standard position, remember, comes from the origin out along the positive side of your x-axis, so that would be your initial ray, and we need to go to pi over 3. Now, I do not recommend you converting it over to degrees. You could always do that to double check, but a lot of times that kind of just makes it more challenging or takes up a lot of time. We know that it's 180 divided by 3. Okay, but let's do without. I know that this bottom piece here tells me how many sections to divide my top half into. And I think about y, we know this is equal to 1 pi. If I want this in 1 pi, it would be 3 pi over 3. So that's 3 sections. So I want to split this into 3 sections. So something like this. Section number 1, if you wanted to label it. Section number 2 would be this section in here, and section number 3. We want 1 pi out of 3. One of those 3 sections. So we're just going to count up 1. So that would be here. And this is where you're going to draw your terminal ray. And then show the rotation. Here it is pi over 3. If you want the reference angle, just going a little bit further, remember that's the positive acute angle from dropping down from the terminal ray to the x-axis. It's this angle in here, which happens to be pi over 3. Practicing with converting it to degrees, if you did want to convert that, it's 180 divided by 3, which we know is going to be 60 degrees. Okay. If a problem is given in radians, you want to leave your answer in radians. If it's given in degrees, you give it back in degrees. Let's look at 5 pi over 6. Doing the same thing, just kind of rough sketching this piece out. The numerator tells us we want 5 out of 6 sections in the denominator. So we are going to split the top half into 6 sections. Whatever your denominator is, that's how many sections you're going to split it into. So I'm just going to rough sketch this out. And I draw these little tick marks just to kind of make my sections. And we know that it comes from the origin out along the positive part of our x-axis. This is section 1, 2, 3, 4, 5, 6. Now obviously the numbers are not really there, it's just to kind of help you guide you for the beginning piece of this. We want 5 out of those 6 sections, so let's count to 5. 1, 2, 3, 4, 5. Our terminal ray is going to be over here. We are going to go ahead and draw that arc, and this represents 5 pi over 6. If you wanted to convert that to degrees, just to double check, it's 5. Ah, my board fell down. 5 times 180 divided by 6. Let me just finish this problem and then I'll redo it. So if I wanted the reference angle here, you want the positive acute angle from the terminal ray, dropping it down to your x-axis that's here. This is theta. If this was 5 out of 6 sections, in order to make one whole, it would be 6 out of 6 sections, right? So we really only have 1 pi over 6 remaining. So the reference angle here is pi over 6. I think I'm just going to paint my wall black so I don't have to deal with this issue moving forward. All right. Pause, we'll come back. Okay, so we are back in business. Tablecloth is back posted up. Let's get to this. We've got 3 pi, and we want to go ahead and sketch this in standard position. So just sketching this out. Remember, the denominator tells you how many sections to cut the top half into. Now, if you think about it, there is no denominator there except for 1. There are a couple ways you can kind of think about it. I'm just going to go ahead and think about pi. Pi is 180. We know pi is here. I'm going to just rough sketch this out. 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. Now remember, standard position starts at the origin, positive x-axis. There we go. All right. We went 1 pi over here. 2 pi is a full rotation or 360, right? So 1 pi. 2 pi, we still need to go an additional pi, which is over here in order to make the 3 pi. So we have this sketched in standard position. What if I said, what's the reference angle? So remember, the reference angle is formed by the terminal ray and the x-axis here. It's the angle that's formed. There is none. This is a quadrantal angle. If it's quadrantal, there is no reference angle. Okay, 2 more examples and then we're finished for today. All right, so these are the last 2 for today. So notice I have some negatives, okay? So if I'm just rough sketching this out, The denominator tells you how many sections to cut the top half into. So if I cut the top half, okay, I've got 1 section, 2 section, 3 section, 4, 5, and 6. But this angle tells us negative. That means from standard position here on the positive side of the x-axis, I'm not going up or counterclockwise, I'm actually going down. So cutting it on the top doesn't help, but 6 sections on half of my graph, I need another 6 sections on the bottom half, right? So think about that. If I have 6 sections and 6 sections, I have 12 sections out of 6, or 12 pi over 6, and that we know is 2 pi, or 1 full rotation, or 360 degrees. So I'm going to cut the bottom half to 6 as well. And I want to count 7 out of the 6 sections. 1 section, 2 section, 3 section, 4 section, 5 sections, 6 sections. But I need to go an additional section, so 7 sections. Notice I counted down. So 1, 2, 3, 4, 5, 6, 7. So my terminal ray is going to lie over here in the second quadrant. And remember, show the arc or the rotation, so down with your arrow pointing that way. So we went negative 7 pi over 6. Now remember, these numbers of the sections are technically not there. The tick marks are technically not there, but I'm going to leave them. They helped me to graph it out or draw it out, and leave it. It's part of your work. If I asked one other question, like what's the reference angle? If I ask for the reference angle, remember, it's the triangle that's formed from the terminal ray and the x-axis, so dropping in that perpendicular. I really want that theta right there. So what is the measurement of this angle? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and so forth. How much is each section worth? And it's worth 1 pi over 6. So the reference angle is pi over 6. Remember, positive acute angle. Lastly, we have this one over here. Once again, we are going down since it is negative. So I'm not going to cut the top half. I'm really just going to cut the bottom half, this time into 4 sections. 1 section, 2 section, 3 section, 4 sections, half. Okay, so I want 3 out of those 4 sections. We're counting down. 1, 2, 3. We lie here. Show the rotation. It is this piece here, and that is negative, or down, 3 pi over 4. Lastly, if I want my reference angle, remember, from the terminal ray down to the x-axis, it's that theta in there. How much is each section worth? Each section is worth 1 pi over 4, since I did 3 pi over 4s, so we have pi over 4 as our reference angle. All right, and that's it for today on converting from degrees to radians, vice versa, and sketching angles in standard position given radians.